go 1, 3, 4, 5. That just don't make sense.
No, like
That sucks having it in the middle.
Next to a
Good morning, ladies and gentlemen. How are we doing today?
I am doing amazing, Mr. Man.
Somebody leave a water bottle here yesterday?
Maybe the other.
Maybe Christian.
Okay, maybe the other Ethan. We'll see. I wonder if they'll be here today. Well, there's a 50-50 chance. All right, ladies and gentlemen, take out your computers and get logged in. We got a couple things to do today. Hold on, I got it. I'm coming. Come on in. You're welcome. All right.
Yeah, it is. That's the correct PR table. How many leaves do I need? How many PR tables and like?
It's not about how many you need. You can only use 2 sheets.
I know that. Like how many of these and these do I need?
Well, that's up for you to decide, Zoe. No one can tell you what you need.
I know I have so many of these, so many of both of these. I was like, how many? Like I have a oversupply last time that I haven't thrown away.
Okay. Oh, Jennifer is here.
I hate my little brother.
Yeah, we all do.
I mean, I did for a good, like...
And I don't even know your little brother.
What's that to do with it?
Thank you, Zoe.
After that, I just started taking...
I will get it. It's Brianna. Brianna's here. Shh. Don't make a big deal. It's Brianna. Hello, Brianna.
It was like a 200...
I know. I didn't get much getting on it. All I have it's like that formula you told us to write down on that periodic table. The like solving formula that we did yesterday.
Okay.
I have all the pressures.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Like the units like
53 milligrams.
all like the units for like pressure, volume, temperature, and amount of mole.
Okay, Zoe. Good. All right. Today, ladies and gentlemen, we are going to do 2 things. We are going to do a lab and we are going to take our quiz today. Okay? Real quick, before we do our lab, name me 3 units for pressure. Give me one. There's 4 units of pressure. Give me one of them. Faith. PSI. That was the one you knew.
Yeah.
Kayana. KPA. Zoe.
mmH3 mercury.
Millimeters of mercury. Very good. And now he remembers. Go ahead, Ethan.
Is ATM one?
Yes. Yes. It stands for atmosphere. Good. Okay. Give me a unit for volume. Someone. Anyone, please. Someone, please. Lucy. Milliliters. Good, Alex. Come on. She gave you half of the unit. Liter. Good. Mariana. Yes, centimeters cubed. Very good. All right, what are our units for temperature? Give me one, Victoria. Celsius. Degrees Celsius. Alexa, what's the other? Kelvin, yes. Now, there is a third. I'll give a bonus question. There is a third. Okay. If only someone would raise their hand.
There's 2.
Okay, Zoe.
There's 2 of them in the hand.
3 with you. Go ahead.
No, I wasn't. I was just pointing to those 2.
Zoe, when you go like this, that's raising your hand.
So don't worry about other people.
Do you got an answer? No? All right. Go ahead, Kayana. Fahrenheit. Degrees Fahrenheit. Degrees Fahrenheit is what they report the weather in, ladies and gentlemen, outside. We don't use that at all in science. Okay, we don't use it at all in science. All right, good. And there's one other thing. That covered pressure, that covered volume, that covered temperature. Then there is amount of substance, and what is the unit for that? Go ahead, Ethan. I asked him. He raises his hand, and now he's questioning.
Mole.
Mole is the unit for amount of substance. Very good. All right, ladies and gentlemen. If we were going to convert from 37 degrees Celsius to Kelvin, what would we do? Add what? 273. Very good. So we would add 273. Now, If you do not have this memorized, you should have it on your periodic table because you are going to need to do it on today's quiz. So your temperature in Celsius plus 273 will give you your temperature in Kelvin. Okay? That will give you your temperature in Kelvin. So 37 plus 273 would give us a temperature of 310 Kelvin. And again, remember, no degree sign with Kelvin. It is just Kelvin. Questions? Okay. So what would a temperature of 183 Kelvin be in degrees Celsius? How would we find it, Zoe?
The temperature minus 273.
Very good. We would take the temperature that we're given, 183. We would subtract 273 from it, ladies and gentlemen, and we would get our temperature in Kelvin, or in degrees Celsius. Okay, can you end it, please?
No.
Thank you. Okay. So we take our temperature in Kelvin minus 273. That gives us our temperature in Celsius. Wait a minute. How can this be a negative temperature?
As long as it's not as high as long as the negative is not higher than the 183
Not exactly, but Alex had the better answer, which was what? In Celsius, you can have negative temperatures. In Celsius, you can have negative temperatures. What is the lowest temperature in Celsius you can have? Negative 273. Now, I would never give you one that would go over that. Okay? So understand, I would never give you one that you can't have. All right? Very good. Very good. Very good. All right. All right. How would we go from 1,200 millimeters of mercury into PSI? What would we do? Go ahead.
So you do the 1,200 millimeter, or
Yep, got it.
so that, and then times
Yep.
the 14.7 on top, and then 760 on the bottom.
Very good. One of the things that I want to stress to you, ladies and gentlemen, let's see if I got it on the next slide. Okay. One of the things I want to stress to you is we gave you 4 pressures yesterday. 4 of them. Okay. Those 4 pressures are what we use to convert from one to another. So when we are given a pressure, give me a number, any number. Kiana, give me a number. 25. So let's do 25 PSI. All right. Pick another unit. Pick a different unit, Brianna, for pressure. Any unit for pressure other than PSI. ATM. Okay. Now, the key to doing this, ladies and gentlemen, is that there are 4 pressures that are equal. 14.7 PSI equals 101.3 kPa equals 1.00 ATM, atmospheres, equals 760 mmHg. These 4 pressures are what we use to go from one unit to another. These are the only things we use, okay? So these are what make up that fraction, okay? These are what make up that fraction, the one on the bottom and the one on the top. Now, the question is which one goes on the bottom and which one goes on the top, and Ethan nailed it, okay? I feel like I'm getting my exercise today, ladies and gentlemen, and I already played basketball this morning. Good morning. Good morning. Okay? So, when you're given a problem like this, ladies and gentlemen, you take and we write down the original number that we were given, a multiplication sign, and then a fraction bar. Part goes on the top, part goes on the bottom. Okay, what's going to go on the bottom here? 14.7 PSI. Again, that comes from these in here. Okay?
And then above is like 1.
I need a doorman.
1.0.
A door person. I need a door person.
You are your
I
own
need
door
someone
person.
to stand outside the door and go, welcome to Mr. Brand's class. How can we help you today? Welcome to Mr. Brand's class. How can we help you today?
Huh?
Ethan, did you leave a water bottle in here yesterday? Does it look like that?
Thank you.
Okay, $3. No, you owe me $3 for overnight storage. Yes, I do. How much what do you got on you? I got 2 singles.
I need 3.
It's $3 overnight storage.
You get 2 back.
I want 3 though.
All right, I'll give you $3 back. I'll give you a discounted rate tonight. Okay. All right. So on the top, what do we put, ladies and gentlemen? Zoe.
So 1.00 ATM.
Very good. 1.00 ATM. So this part right here, ladies and gentlemen, that didn't work good. This part right here is always made out of these. Okay? Always made out of these. One goes on the top, one goes on the bottom. Now again, how do we figure out which one goes where? It's a matter of we want our units to cancel, and PSI will cancel with these PSI. We will be left in a unit of ATM. We're good to go here. Okay? I'm not going to work it out. We can do that.
Are you serious?
Apparently we are, Zoe. Apparently we are. But here's the good news. I don't have quite so many quizzes to worry about making up next week. That's good.
I mean, are you serious? Well, people at
That's
the
good.
door.
That's good.
What are you talking about, Zoe?
I know. It's okay, Zoe. It's okay, Zoe. It's not mandatory to be here on time anymore. All right. All right.
I was sitting here before you got here.
Yeah.
So just sit down.
Hey, pick a spot. There are no assigned seats. There's a bunch of empty desks in the room. Pick one and sit your butt in it. There we go. There we go. Hey, you know how you could solve this problem? Get here on time. Then you get a better choice of selection. Holy cow. We went from, we only got one missing now. We're waiting for Kevin. I will only have to open the door one more time this hour, possibly. All right. I don't think he's going to make it either, but that's okay. All right. So there we go, ladies and gentlemen. Questions. All right. Go into your computer, ladies and gentlemen, and find the assignment in Google Classroom that says Implosion Lab and open it up. That is the lab that we are going to work on today, ladies and gentlemen. And then after the lab, we will go ahead and we will do our quiz. Okay. All right. When you open up the Implosion Lab, ladies and gentlemen, here is what it looks like. The Implosion Mini Lab. We are going to study the effects of air pressure during changes in temperature. Okay. I changed that this morning. This is probably what yours means. So you are going to fill a clean and empty pop can, and they are in the box right behind you on that cart, ladies and gentlemen. So you will each grab a clean and empty soda can. You are going to fill it with about 15 milliliters of water. There are pitchers at your desk at the lab stations, ladies and gentlemen. You can grab one and fill it. Okay? Now, each of you is going to do your own can today, okay? Each of you is going to do your own can. So even if you have a partner, you can work at the same lab station, but you will both do that, okay? So there are graduated cylinders out there, ladies and gentlemen, but the 15 milliliters is about 15 milliliters, so you don't have to spend a lot of time dumping in and out to get it exact. So take and put about 15 milliliters of water in here. Okay, again, just approximately, and then you're going to pour it into your can. Okay, you're going to then put your can on the hot plate. The hot plate will hold up to 4 cans. Okay, you are going to turn the heat all the way to high. Please make sure it is the heat and not the stir button. If you turn on the stir, you will be there all day and nothing will happen. Okay, because it's not going to stir the can. Okay, so you're going to put it on the hot plate until you see steam coming out of it for about a minute or two. Okay? So steam coming out of it for about a minute or two. Now, you are going to make observations of the boiling water in the can. Does it make any sounds? What do you see? What do you feel? What do you smell? Don't taste anything. Okay? So you're going to make 3 observations here. Okay? While the can is heating, you're going to set up an ice water bath. I already got it done for you. It's already out there waiting for you. They are these. Okay? While the water is, the can is still boiling, you are going to quickly transfer it from the hot plate into the cold water bath. When you do, ladies and gentlemen, you will use a hot hand. Okay? Because if the water is boiling in the can, what's the temperature of the can?
Hot.
About 100 degrees Celsius. Same as boiling water, and I don't think you would grab boiling water with your bare hand. Okay? So you grab it, and as quickly as you can, you take it, turn it upside down into the water bath, and hold it there. Okay? And wait for something to happen. If nothing happens, you got to put 15 mils back in here and do it again. Okay? If something happens, you will know it happens. Questions?
What's supposed to happen?
Well, you'll see. Well, I don't know what's supposed to happen. We'll see what happens.
That's a lie.
Okay, go to work. Let's go. By the way, don't forget to make observations of what happens when you place the can. By the way, hello, last thing. Please, 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 do not throw the can at the water. Take the can, hold it upside down underneath the water for the best results. All right, I will return this to the station I borrowed it from. The station right there that Lucy's going to on this side, though, I don't have anything set up there. Could you use the one behind it, please? Alex, I'm going to sneak in there with this water bath. You can stay here and work. I'm just sneaking in. There you go. You guys are good. Okay. I'm betting on you. Hey, just so you know, Kiana, I'm betting on you. I'll tell you why later, but I'm betting on you. I'm betting on you. Okay? I'm betting on you. I'll tell you afterwards. Go ahead, do the experiment. But I'm betting on you being the person. Guys, there's nothing set up there, so you gotta work right there. Grab your kids. Go to work. Okay. Okay. I got Kleenex in the front. Grab some if you need some. All the way up, as high as you can get on your hot plate when you turn it on. As hot as you can get. You just use the one. Yeah, just use the one out there. Just there's some kind of hold. Just spread them out a little bit so that you grab it easier when you go to it in water. Make sure your computer stays away from the water bath so you don't accidentally spill water on your computer, short circuit your computer, and then they yell at me in the office for that.
I got those ones. Is that good?
You can put 4 cans on there, put them in the 4 corners, that's fine. Watch your can. When your can is starting to steam, give it about another minute or 2, and then you'll be the one that flips it over. You know what? I might want to take my bet back. I'm going to go with Kiana or Faith. Just saying. Just saying. That's my bet. Kiana or Faith.
Right in the middle.
Don't pour over your computer though, please, in case you accidentally spill.
Best soda ever.
Yes. Grab one. I got one. Told you. I told you. Faith would be one who screams. Hey, Anna, you did better. I thought you would be one. Nice job. One for one today, ladies and gentlemen. One for one. Look, did you deserve? Oh, no. Zero. When you're all done at your station, please turn off your hot plate. Leave that. Okay, the cans that have been pressed, please bring over here and put them on this truck. Make sure your hot plate is off, and then you can go out and see. Your observation again. If there's a lot of water at your station, please wipe it off. leave it sitting there and then make sure everything is back. Make sure your hot plate is off. She knows what's going to happen. Here we go. No pressure. Oh, here's the one that goes the other direction. You only have to. You'll be fine. Very little damage to the last person. Go. She didn't scream. I had to press. All right. Grab a seat, please, ladies and gentlemen. All right. Now, please make sure you have your 3 observations here and 3 observations here. That is half the lab, ladies and gentlemen. The other half we're going to do right now together. So make sure you have 3 observations here, 3 observations here. Okay. Now, first of all, what happened to the can? Zoe.
When we put
All I want to know is what happened to the can.
it exploded when they put it
It
in
did
the ice
not
bath.
explode. It did not explode.
It like popped.
It imploded. What is the difference between an explosion and an implosion? It goes in instead of out. Now, this is what unfortunately happened last summer to the 3 people who went down in that homemade submarine to look at the Titanic. They were in a cylinder and it imploded from the pressure of the water around it. What? His was much bigger. But, ladies and gentlemen, water did not implode these cans. What did?
Pressure.
What pressure?
Water pressure.
It was not water pressure. You did not stick this completely under the water. The water was not, you put the top of this underwater. Water wasn't getting at these sides here. What was? There was no heat there.
Temperature.
What? You're close.
The amount of pressure.
Air. Air pressure. Air pressure is what crushed this can. Okay? Now, to do that, what does that mean for the pressure inside the can? It had to be what? Think about our demonstrations the other day. Air pressure always goes from what to what? Think about the glass jar on the plate. Air pressure always goes from what area to what area? Nope, not outside to in always. Okay, but what's different about them? The amount of what?
Amount of pressure.
Pressure. So, okay, let's do a comparison. You can have low pressure and you can have high pressure. Which way does air pressure always go? From what to what? No, not from outside to in. High to low. High to low. So, what would have caused the can to crush? Zoe, I hope you're not typing all this yet, because we're going to get there, okay? What caused the can to crush? Changes in pressure. So where did the low pressure have to be? This isn't about the water. This is about air pressure. Air pressure inside the can and air pressure outside.
Inside the can.
Correct. We created an area of low pressure inside the can. That caused the high pressure outside to crush it. Now, that didn't happen with our glass jar. Why? Glass is much stronger than aluminum. Okay? But do you remember the two spheres that we had people trying to pull apart and they had difficulty doing it?
Yeah.
That's the air pressure trying to get into that area of low pressure. High pressure always tries to fill in low pressure. That's how a suction cup works. That is what ultimately caused this can to crush. Okay? So let's begin our conclusion with high air pressure outside the can. High air pressure outside the can tried to fill in low pressure inside the can and caused it to crush.
I do.
High pressure outside the can tried to fill in low pressure inside the can and the can crushed.
I do feel. High pressure, like high air pressure outside the can, tried to fill air pressure.
Low air pressure inside the can and the can crushed. Okay.
Supposed to come out bad. It's what a glass bottle though.
And I kind of heard it pop also.
Okay. That pop was what? What was the pop actually?
Air escaping?
No, because the air couldn't escape. The air was trying to get where? Inside the can.
It was like
So what was the pop?
crushing the can.
The can crushing. The can crushing. The can actually crushing all at once. It popped. Why? Because it couldn't take any more pressure. Boom. Okay? These are two great examples of what happened. Okay? All right. Now, a couple of questions here. Why did we add water and boil it at the start? Okay, Anna.
To create a change in temperature.
Okay, but remember, what caused the can to crush? Air pressure, right? So water is not air, correct? But what did heating the water do inside the can? So,
Went from high air pressure to low air pressure.
but how? Well, wait a minute. If that were the case, if it went from high pressure to low pressure, why didn't the can crush while it was being heated?
Because it was low pressure.
What?
Low pressure.
What did?
The water boiling inside the inside of the can low pressure.
Actually, what happened to the steam, the vapor that was created inside the can?
It escaped.
Which means, what kind of air pressure was inside the can when you were heating it? Hot. Kiana, you had something you wanted to add.
No, the other question is that. Like, oh, steam.
Okay.
Yeah.
So why did we boil the water? To create particles of gas that were moving very what? Fast. And they were actually taking up more space, right?
Right.
So what did they do? What did we see them do? No.
Create steam.
Which did what?
Cause
How did you know when your can was ready to go?
It was boiling.
the steam.
How do you saw the steam coming out of it? You saw the steam coming out of it. So why did we boil water at the start? To create a hot gas. To create a hot gas inside the can. To create a hot gas. Why? Hot gases take up more space. Hot gases take up more space. So why did we add water and boil it at the start? to create a hot gas inside the container. To create a hot gas inside the container. Hot gases take up more space because they are moving much faster. That's why we saw steam coming out of the top. So we created a hot gas inside there. So then you tell me what happened when we used the ice bath.
They go with the.
No. What did the ice bath actually do?
Go with the pressure and made it implode.
What the
pressure?
Don't think pressure.
Cool the can.
It cooled not the can. It did cool the can down. But more importantly, it cooled down the what?
The water.
The gas.
The gas inside. Remember, we're talking about gas having an effect here, right? So what did the ice water bath do? It quickly cooled down the gas inside. The ice bath quickly cooled down the gas inside. So the ice water quickly cooled down the gas inside the can.
Mr. Bernard, are you gonna have enough time to do our test, please?
Yeah, it's only going to take about 20 minutes to do the quiz. We still got 30 some minutes
I
left.
didn't know how many questions it was.
It's a 20 question one like normal. It won't take you that long. Okay, I think it's around 20. One of them is a matching section, so it's not actually 20 questions. Okay. Now think about this. At the start, we heated the water in the can, which caused the gas to do what? Become steam, hot steam, and hot steam takes up more space. So when we cool the gas, it becomes cold
And
takes up
less space.
Creating an area of low pressure inside. Now, last question. Why was it important that when we put the can in the water bath that we turned it over?
So it couldn't escape.
Well, wait a minute. Which way was the air trying to
So
go?
we could create less space.
That's all the exit.
I'm sorry, I can't hear you. Christopher, what's the answer?
I don't know.
Okay, then why don't we listen to other people who are trying to give it to you? I'm sorry.
It's the same entrance exit that the steam or
Okay.
enter exit.
So if we had put the can in like this, air pressure could do what? It's not trying to escape though. You guys are forgetting. Where is air pressure trying to go? Into the can. That's the area of low pressure, right?
Yeah.
And if I put the can in the water like this, what's the air pressure going to do? Like this? Why can't it get in? What is this?
The hole.
That's a hole. That's how you put the water in. And if we put the can in like this, what would have happened? Nothing. The air pressure would have gone in and filled it up. But by turning it over, what did that do?
Created
Forced it. You put the air pressure into the submerged.
and create a pop.
By putting this underwater, you created a seal. Air cannot go through the water up and into the can. So instead, it goes from the outside in. Okay? So, why did we turn the can upside down? To create a seal so that air could not just go into the can. We created a seal so that air could not just go into the can. Okay? Right, guys? What do we do?
Created a seal.
So that.
They couldn't get out. That's right.
Okay, well, you listened to part of it.
It couldn't get in.
It couldn't get in. It couldn't get in. So by turning the can upside down, we created a seal so that air could not get in. So then instead, what did it do? It pushed through the sides.
And it popped.
It said, I'm going to fill in that space.
Custom
How?
pop.
I'm going to make that space smaller. That's me filling it in.
Custom pop.
And then it crushed and popped. Now, you should be done with this quiz, ladies, or the lab, ladies and gentlemen, and you should be able to turn it in and get full credit for it because we just went through literally everything. So before you leave today, ladies and gentlemen, please make sure you turn this in. Why? There's no reason for you not to. We just went over it. Anyone have any questions? All right, ladies and gentlemen, turn the lab in. Take and pull out your periodic table. Okay? Put it on your desk. You may need a calculator for doing the conversions from Celsius to Kelvin or Kelvin to Celsius. So if you need a calculator, ladies and gentlemen, you can come up and grab one of mine. Helen, what can I do for you?
And I got a piece of stuff.
Can you wait till we get going on the quiz or till I can tell those instructions and then you can go right away and then finish your quiz afterwards?
And if I have to stay doing home base to finish it.
I don't think you will need to. You should have plenty of time to finish it. Let's try to get it done in the next 31 minutes.
Are we going to do the conversions on here then too?
What?
Are we going to do the conversions?
I don't think there are any pressure conversions on here. I don't think there are any on here. I could be wrong, but I don't think so. If there are, you can come up and grab a sheet of scratch paper, but I don't think you need to do it. The only ones you need to do are the ones for Celsius and Kelvin.
That's why I got this scratch paper just in case.
That's fine. All right?
We were doing ones like we did yesterday.
Okay. So here we go, ladies and gentlemen. I'm going to open up your quizzes for you. When you are done with the quiz, if you have not already done so, turn in your lab. If you have turned in your lab, then you're done for me for the day. By the way, we'll make the lab due today. There's no reason for you to carry it over until Monday. Get it done, get it turned in today. All right, classwork. Edit. Okay. The quiz is assigned, ladies and gentlemen. The quiz is accepting responses. Again, the first few questions where you have to provide your own answer. Please make sure that you answer it completely. It does not need to be in the form of a complete sentence. Go to work, ladies and gentlemen. Go to work, go to work, go to work.